Tuesday. Sometimes the quadratic is given in factored form, such as y equals x minus 1 times x plus 2. We'll use the area model to change the equation to standard form, to multiply these two binomials. We'll set the table and to keep track. Notice that you've got x minus 1 up here, right there, and you've got x plus 2 right here. Multiplying these, we're going to get clearly x times x equals x squared. So remember, we're multiplying this x times both of these terms here, right? So then the next box goes x times negative 1, which is negative x, and then 2 times both these terms becomes 2x, and negative 1 times 2 is negative 2. These are going to be like terms here, so that when we put these together, we're going to have an x squared, a minus x plus 2x becomes plus x minus 2. Or down here, you've got x squared plus x minus 2. I am going to do this one more time in as a double distributive. So this becomes x from this term here times x plus 2 from this term here, and then the minus 1 from the first binomial times x plus 2 gives you x squared plus 2x minus x minus 2. Those are like terms, x squared plus x minus 2. And notice that these answers should very much be the same. Y does equal all this. What does the y-intercept for the equation, what is it? So real quick, you know, if you're looking for the y-intercept, then x equals 0, so y equals 0 minus 1 times 0 plus 2, which is negative 1 times 2, or y equals negative 2. What is another way? Well, remember you had the equation x squared plus x minus 2, right? And you'll notice that if x goes to 0, then what's left is y equals negative 2. But that came from the standard form. All right, so we're going to go ahead and work through a couple of these. Notice that they've got two different boxes, one for the area model, one for the double distributive model or the distributive model, and we're just going to work through these. I'll work through the first one and then just post solutions for the others. So 4x squared plus 5x minus 3, 2x plus 4. As we multiply through, we're going to have 2 times 4 is 8x cubed plus 10x minus 6x, and this should have been x squared, shouldn't it? And then this next row times 4 goes 8x squared plus 20x minus 12, and we're looking for collecting like terms, and these are usually going to show up in the diagonals. 8x cubed plus 18x squared plus 14x minus 12. Let's see if we get the same answer over here using the distributive property. I'm going to use that term first. So 2x times 4x squared plus 5x minus 3 plus 4 times 4x squared plus 5x minus 3. Distribute, we got 8x cubed plus 10x squared minus 6x plus 16x squared plus 20x 4 times 3 is negative 12. And you'll notice that I made a mistake in the first one, didn't you? The mistake should have been over here. Where is this? When I multiplied 4 times 4, I got 8. That should have been 16 right there. 16 plus 10 is 26x squared, so this should have been a 26. Let's see if we get the same answer over here. 8x cubed plus 10x plus 16x is going to be plus 26x squared minus 6x plus 20x gives me plus 14x minus 12, and those answers should match up. And notice it does make a difference if you multiply correctly. Okay, and again, you'll notice that we've reversed the order, but same problems, distributive property versus the area model. The answers come out the same. Try them both. Make sure you understand them both and choose which one you like better. Ian started to multiply the polynomials using the area model. The answer to the question to help Ian finish the problem. Where does the x to the fourth come from? It comes from those multiplying those two. So this becomes negative x cubed. This will become plus 6x cubed. This is going to become 0. This is going to become minus 5x. As you go through these, notice the cubics, the squares, the x's all add up. They put the answer down here. This should have been x to the fourth. 5x cubed, that's going to be minus 6x squared. Minus 6x squared is what they're asking. 5x and then plus 5. So x to the fourth plus 5x cubed minus 6x squared minus 5x plus 5 in terms of filling this out. A little fast there, wasn't I? Okay, and the summary goes back to what we've just been doing. Which method do you like better? I like the distributive method myself, or the FOIL method. They're pretty much one and the same.